evaluate this integral, and the question gives us the hint x equals to secant theta. Let's use it. So let x equals to secant theta. Now we find the derivative of both sides with respect to theta. So dx over d theta, I moved d theta to the other side. So derivative of secant is secant tangent. Okay. Then let's plug in here, but we can work a little bit. Square root of x minus 4. Let's look at that. Okay. What is square root of x squared minus 4? That is, with this substitution, x squared means 2 secant theta squared. So 2 squared 4 secant squared theta minus 4. Let's simplify. Inside this radical sign, we can factor 4 out. Secant squared theta minus 1. And that is square root of 4. Secant squared theta minus 1 is a trig identity. That's tangent theta. Okay. Tangent is square theta. And when we take a square root, this will be 2 tangent theta. Okay. So we are using the fact that 1 plus tangent square is secant square. If we subtract 1 from both sides, we get secant square minus 1. That is tangent square. And that's what I used here. So then this integral now becomes, okay, then the integral is on the top square root of x squared minus 4. We work out this 2 tangent theta. On the bottom x, which we assume 2 secant theta, times dx, and dx is found here, 2 secant theta tangent theta d theta. 2 secant theta tangent theta d theta. Okay, let's make this separate. Okay, and then here we see cancellations. 2 on the top, 2, or we could have cancelled this same thing, secant secant. Then that leaves 2 tangent tangent d theta. They are on the top. Tangent times tangent, tangent is square. So 2 tangent square theta d theta. Now we need to integrate. We know the antiderivative of secant square, which is tangent, but for tangent square there is no easy one. So no direct one, I mean. We can pull 2 outside. Now secant square, let's convert this into secant square. Then we have formula. Again, looking at this one, look at the backward here. Tangent square is secant square minus 1. And that's basically coming from here, this base formula. So tangent square is secant square minus 1. How does this help? Now we know the antiderivative of secant square. That's tangent. Okay. So this one is, now let's integrate. So we do have 2 outside. Antiderivative of secant square, the first term is just tangent, minus antiderivative of 1 is x, but our variable is theta, so theta plus c. We were done. We found the integral everything, but unfortunately look at the question. This is given in terms of x and our answer is in terms of theta. So we need to back substitute theta with nice numbers and get back to x. Okay. So tangent theta, from this assumption, whenever we use this assumption, let me write one more time, x equals to secant theta. From this, we can always find tangent, I mean any trig function. So we need to use a right triangle. And theta would be, we can also find that from here. So let me work that. x equals 2 secant theta using that one. Okay, so our assumption was x equals 2 secant theta. That's the beginning. Divide by 2, we get ax equals 2 equals secant theta. But we are not that much familiar with secant, cosecant. I mean, we are more familiar with cosecant. So, I mean cosine, my bad. Sine, cosines are better. Sine, cosine, tangent. But here, secant, cosine is reciprocal of this secant. So if we flip this fraction, we get cosine. So cosine is 2 over x. Okay, secant to cosine, just the reciprocal. And we know that from SOHCAHTOA, this rule, I'm trying to get a right triangle. Cosine is adjacent over hypotenuse. So we can draw a right triangle with theta, and cosine is adjacent over hypotenuse, right? So adjacent means this side is 2 over x, means this is adjacent, and hypotenuse, this is x. So this opposite side, the perpendicular, this opposite side is missing. So we need to find this side. We know that a square, I mean this is like b. So from here, Pythagorean theorem, a square, this is b, let's say we don't know that, b square equals a square plus b square equals x square, c square. This is a 4, subtract 4 from both sides, so x square minus 4. So b will be square root of that. And this radical sign should be related to the question. I mean, here is 1, and that's always the case. So we found all 3 sides of this right triangle. Then we can go back. Okay, let me separate this one. Then we can go back and write down the final answer. 2 times tangent is TOA, opposite over adjacent. So in this case, b over 2. b is found to be this, square root of x square minus 4 over 2 minus theta. Okay, theta we can write in terms of trig, inverse trig function. From this one, cosine theta is 2 over x, means theta is just arc cosine, cosine inverse of 2 over x. Okay, or we could have gone from here as well, secant, but this is better in terms of cosine. So theta is cosine inverse of 2 over x plus c. So this is the final answer.